Okay, I'm going to attempt to do a very quick tutorial on money creation. So in order to understand this, hopefully you've read about it already, and hopefully you were in class and you saw the whole lecture. So this is just some reminders. These are some equations we need to know. Basically, here's a key to what all the abbreviations stand for, but total reserves is always equal to a bank's required reserves plus their excess reserves. Okay? Total reserves comes from deposits, but does not always equal deposits because those deposits get loaned out. So another way to think of this is it's all the cash a bank owns, okay? And the excess reserves are what can be loaned. Okay, PMC stands for potential money creation, and it's found by taking what we'll call the money multiplier and multiplying that by the excess reserves. TMS stands for total money supply, and it is found by taking PMC and adding demand deposits, or another way to do this is actually demand deposit times your money multiplier. That's an alternative way. The money multiplier is found by taking the number 1 and dividing by what I call .RR, which just means the reserve requirement expressed as a decimal. So if the reserve requirement's 10%, that would be 1 divided by 0.10. Okay, so you can read through these if you'd like. I am going to move on ahead because I want to make this short. Okay, so here is an example of what we mean by this. This is just an example of how the formulas work. Okay, we'll go through why the formulas work in a second. So Ron Swanson deposits $1 with a 10% reserve requirement at his bank. That means that from that dollar, the bank is going to take 10 cents, that's 10% of it, and put it in their required reserves. The other 90 cents, that's 90%, is going to go towards its excess reserves, meaning the bank can now loan to a customer 90 cents. Okay? The total reserves then is the $1, because total reserves is always equal to the required reserves plus the excess reserves. Now, using the potential money creation formula, we could then make the assumption that if the 90 cents were to be loaned out, and then the entire banking system maximized all of their loans that might proceed from the 90 cents, then the PMC is going to equal 10, that's our money multiplier, times 0.90, that's the 90 cents, so 9 additional dollars could be created. Now, this assumes, let's wait for this announcement. Okay. What this assumes is that the 90-cent loan is going to end up getting deposited into another bank that will then set aside 10%, loan out 90%, and so on down the line. Okay? Now, the total money supply, assuming that this is the only dollar that is in existence, the total money supply could become, like I said, PMC plus DD, or $10. Okay? So that's how the money creation process would work. Now, this is when Ron Swanson deposits $1 in his bank. Okay? Now, his bank can get dollars from other sources. Okay? The Federal Reserve is the lender of last resort for banks. So the Federal Reserve could loan Ron Swanson's bank $1. Okay? Now, the reserve requirement only applies to deposits. So that means that none of this dollar is required to go to required reserves. That means the entire dollar goes to excess reserves. So anytime the bank deals directly with the Fed and money's involved, there are no required reserves. Okay? The entire dollar goes to excess reserves. Excess reserves plus required reserves still equals total reserves. And now the potential money creation, we still have a money multiplier because the entire banking system is still subject to the 10% reserve requirement. So the money multiplier is 1 divided by 0.1, or 10. The excess reserves in this case is $1, so 10 times $1 equals $10. Now, total money supply is still TMS equal to PMC plus DD. Well, there is no demand deposit in this case, so total money supply is just equal to potential money created. Okay, so that's kind of an idea of how to use the formulas. Okay, so what I'm going to do now is show you why it is that the money creation process actually works. Okay. I guess Ern's going to give us some information. All right. So we're going to assume that Ashley deposits $100 in her bank, and that the reserve requirement is 10%. Okay. Now we have to remember or recall that the money supply is equal to our currency and our demand deposits. So if we make the assumption that the only money that exists is Ashley's $100, and she currently doesn't have a demand deposit, then the money supply before we do anything is $100. Okay? Now, if she takes that 100 and deposits it, okay, the next step here is that now we have $100 in a checking account, and there's $0 of currency floating around out there. So whenever you make a deposit, initially nothing changes. Okay? Now, let's remind ourselves, reserve requirement equals 10%. That means this bank is going to set aside 10% of this 100, but they're going to loan out the other 90. So if somebody comes and borrows the 90, puts it in their pocket, now there's $90 of currency floating around out there. But Ashley still has $100 in her checking account. Okay? So the loan process just created an additional $90. So now the money supply is $190. Now let's pretend this 90 gets deposited into another checking account. Now you got 190 in checking accounts, 0 in currency. So no change there until the 90 is able to be loaned out. Now they can't loan out the whole 90. Okay? So in the second demand deposit, in fact we could break this out. There's Ashley's deposit of 100 and now the second one of 90. Okay? The $90 in the second bank, 10% of it needs to be set aside, but the other 90% can be loaned out. So this second bank is going to loan out $81 that somebody has now in cash that's sitting in their pocket. And we still have 190 in demand deposits. So the loan process just created more money. Okay? Eventually, over time, what's going to happen is all of the actual currency that exists in the banking system is going to be tied up in required reserves. But the rest of the created money will be demand deposits. And so eventually, the money supply is going to end up growing to be as large as 1,000. Okay? And that 1,000 is basically going to be all of the demand deposits. So that's how the money creation process works. Okay, we don't have to go through every iteration of deposit and loan and deposit and loan and so on. Instead, we can just use our actual formulas. Here's another way to look at this. Okay, if $1,000 is deposited into a bank, and that bank has a reserve requirement of 20%. Okay, that means that bank has to set aside $200, but then they can loan out the rest. So let's pretend that Nick borrows $800 so that he can buy an RJ bobblehead. Okay, the bobblehead company is going to deposit the $800 into their bank. All right? Now, that $800 comes over here as a new deposit. 20% of that $800 has to be set aside. The other $640 can be loaned out. Okay? My friend Corbin borrows the $640 so that he can commission an oil painting of himself. The artist will deposit that $640 in her bank. Okay? So we have another deposit, $640. 20% of that is set aside. The rest of it is available for loans. Okay, these loans, somebody's going to borrow it. I guess it's going to be this guy, so he can get new piercings. Okay, and the piercing professional deposits that in their bank, and the process continues on. Okay, we'll just stop here. Christine borrows $409 to buy new hairnets for her and her friends. Okay. And then that gets deposited and so on. It just keeps on going and going and going. Eventually, the original cash amount is going to be tied up in required reserves. This is going to add up to 1,000 eventually. Okay? The new money created is the actual loans that proceed from the initial deposit. So what we're going to end up having is the $800 of excess reserves. If we multiplied it by the money multiplier, which in this case, okay, money multiplier is going to be 1 divided by 0.20, so 5. Okay, 5 times 800 is 4,000. Okay, so the new money created is right here, 4,000. If we added up every single deposit, and then we add that to the initial amount of cash that existed, so now the total money supply would be as large as 5,000. This assumes that every bank loans out all of its excess reserves and it assumes that every loan proceeds gets deposited into another bank. That rarely actually happens, so the money multiplier will be much less than what we suggest it is, but potentially this is how the money supply could grow. Okay? All right. I'll just do a couple of examples here. Well, I'll answer some of these questions because they're similar to what you'll see on your homework. So Katy Perry deposits $40 billion into the banking system, and the legal reserve requirement is 20%. When she makes a deposit of cash into a demand deposit, the money supply actually stays exactly the same. Okay? No changes there. All right? Now, the $40 billion deposit of currency into checking accounts will create excess reserves of how much? So what I'd like for you to do every time you face one of these problems is write this equation out and see if you can figure it out using that. So the 40 becomes part of the total reserves. Of the 40, 20% of it has to be required reserves. That means the remaining of the 40 becomes excess reserves. So to answer number 2, the $40 billion deposit of currency into checking accounts will create excess reserves of $32 billion. Okay? The potential money creation through the banking system, if they loan out all of their excess reserves, is going to end up being, let's just write that out. Okay? PMC equals, what does it equal? The money multiplier times the excess reserves. Our excess reserves are 32. Our money multiplier is 5. So potentially, 160 billion in new money could be created, okay? Which would make the potential total money supply, that means all the demand deposits, including Katie's original 40 billion, is going to add up to 200 billion. That's basically coming from this 40 and this 160, okay? They add up to 200 billion. So, as a reminder, here are your formulations. Some of them are rewritten in different order. Y'all can do that on your own. A couple of notes here. Remember, there's a difference between money that comes from the public, meaning a demand deposit is involved, and money that comes from the Fed, where there is no demand deposit. Okay, so keep that in mind. So, a couple little notes here. The reserve requirement, it applies to checkable deposits where? Everywhere. Okay? So here's another example. If the Friar Bank has excess reserves of $6,000 and demand deposits of $100,000, what is the size of the bank's total reserves if the reserve requirement is 25%? Once again, I want you to always start here. Okay? And once you do this multiple times, you're going to get in the habit, or you're going to understand it well enough where you can do this in your head. Okay? And then fill in the given information. So you were given the ER is 6,000. Put that in. Okay? And you were given that demand deposits are 100,000. All right? Now here's something you got to keep in mind. That $100,000 may have at one point in time been all of the bank's cash and therefore part of total reserves. Today, though, it is not, because we know that a lot of those deposits got loaned out. Okay? So what we really know from this information is that of this 100,000, 25% of it still is at the bank because it's part of the total reserves. So, part of the required reserves, rather. So 25,000 is required reserves. So the answer to our question is 31,000. Okay, 31,000 is part of, or is the total reserves. So we've answered that question. Okay, these are just some of the types of problems that you're going to see on tests, quizzes, homework, and so on. Okay, last page. We're going to, I'll answer these as examples, and then you can get busy on your own. All right, Caitlin deposits $1,000 in a bank that has a reserve requirement of 10%. The maximum possible change in the dollar value of this bank's loans would be, well, again, we can always start with this, okay? Now, this deposit is not necessarily the bank's entire total reserves, but we're going to play this game here where we're going to say 1,000 of it becomes part of total reserves. Of that 1,000, 10% of it becomes required reserves. The other 900 is the bank's excess reserves. This is what the bank is allowed to loan. So the dollar value of the bank's loans is going to be $900. Now, if that bank and then subsequently every recipient of every loan deposits the loan, and then every other bank also maximizes their loans, then potentially new money in the banking system could be as much as 9,000. Why do we know that? Because PNC is our money multiplier times our excess reserves. Okay, this was 900. Money multiplier is 10 because it's 1 divided by 0.10. Therefore, this is always 9,000, or in this case is 9,000. Okay, and then the total money supply, what we're going to do there is just add Caitlin's original deposit to the PNC, and so we get 10,000. All right, here's another one. Suppose a commercial bank has demand deposits of 100,000, the reserve requirement's 10%. If the bank's RR and ER are equal, then its total reserves are how much? Okay. Once again, we're going to fill out our information. TR equals RR plus ER. Okay. It says that these two things here are equal. So if we know one of them, we'll know the other one. So the reserve requirement's 10%. That means 10% of this is the RR. That means this is also 10,000 because we were told they were equal. So total reserves is 20,000. This is really actually not a complicated thing, but when we start throwing all of these numbers around, it gets complicated. Thus, that is why you have to practice it. I want to make sure you get it straight. All right, so that's it. Y'all go to town, have fun. I will always remind you, though, I didn't do an example like this necessarily, but remember, when you're talking about money from the Fed, there is no demand deposit. So reason